All right. Hello, Epidemics. Welcome back. Looks like we have hopefully just a few people coming in late because kind of low attendance today. But we're going to talk about smallpox anyway. So only one person put something in the comment about today's puzzle. If you have 6 eggs, break 2, cook 2, and eat 2, how many eggs are left? That's right, it's 4, because the 2 that you cook and the 2 that you eat are the same as the 2 that you break. Good, that one was, you guys got that one. All right, announcements. There's a quiz and a journal prompt, both due Sunday. Whoops. This should say February 27th. Both of them are due February 27th before midnight. And the project request due date is coming up. It's due before midnight on Sunday, March 6th. And the request needs to include a topic and how you intend to present the information. A paper, a presentation. Nate, go ahead.
Just a quick question about the approval process.
Yes.
You know, I obviously submitted it. I got a 1. I know that means you had some suggestions or recommendations. I don't know if you already put comments or had, I guess what I'm saying is, how do I know what corrections you want me to add or what things you'd wanted to change? I didn't see any like remarks on the under my grades. I don't know if you did put that. I was just curious because I didn't see anything.
I did put comments.
I think it was listed as a test, so I wasn't able to go in there and view anything.
Okay.
Yeah, I'm like 99% sure that was the case because I remember going into it and like looking for that comment bubble and it said, this test has already been submitted, something like along that lines, if you're getting what I'm saying.
I get what you're saying. After class, I'll go in and see if I can fix that for you.
Okay, yeah. I appreciate that. Sorry
No
for
problem.
the hiccup.
No, that's not a problem. That's what this time is for. All right, so when we met last time, we were talking about smallpox. And with smallpox, the survivors had lifelong immunity. Which is not something you get with all diseases. So it's one of the many things that made it easier to eliminate smallpox and to eliminate a lot of other diseases. And we talked briefly about herd immunity, and I wanted to kind of repeat that because it's something that I think a lot of people misunderstand. So herd immunity, when a significant percentage of the population is immune, the few who aren't immune are not exposed to that disease, simply because there isn't somebody with the disease that they bump into and interact with. Herd immunity is not permanent for most diseases. new people are born, they're susceptible. People get old, their immunity wanes, so they become more susceptible. So you can recreate vulnerability in a population and lose that herd immunity over time. You can get herd immunity either because enough people got the disease and now have an immune response, or through vaccination. If you do it the so-called natural way, what happens is that people get the disease and they get sick and they die. If you vaccinate, it's incredibly, incredibly rare for people to die from a vaccine. And in fact, the only case I know of, the vaccine was the person giving the vaccine mixed up the vial of the vaccines with the vial of another medication, and the other medication was given at such a high dose it was lethal. That is literally the only case I know of somebody who died from a vaccine. Now, some vaccines, like the early polio vaccines, would cause breakthrough infections in some people, and that could certainly kill people. Our modern vaccines, none of them can cause breakthrough infections. And when we talk about vaccines, I'll explain why that is. Okay, so for herd immunity, the amount, do I have another slide here? The percentage of the population that needs to be immune really varies by disease. And different locations are going to have different numbers based on population density and mixing. So how many people do you interact with on a daily basis? How many people live in a community? How many people move into a new community from another community? All of these things are going to impact exactly how much of the population that needs to be immune. The biggest one is whooping cough, which is 95% immunity. It's very, very contagious. Measles, the immunity is like 90%. Measles is very, very infectious as well. Nate, go ahead.
Sorry about that. I'm mobile, so my thumbs are way too big for these buttons. For whooping cough, that's also like the scientific term. That's pertussis, right?
Yes.
Okay, just wondering about that. Thanks.
Back to the whooping cough, Professor. Was the medicine like this pink medicine liquid you had to drink for it? So I remember having that in Georgia when I was a kid. Random question, sorry.
Yeah, I don't know what medicine they treat people with, or what they treated you with in the past, which may not be what they use today.
Sounds like amoxicillin. I could be wrong though.
Possibly. I just remember that.
Yeah, that sounds like amoxicillin.
Hockey, but pink.
Yeah,
yeah, it looks like Pepto, kind of, but not the same thing. But yeah, it is pink. Amoxicillin's like a pink, well, the ingestible form, not the pill. But yeah, you're right.
Would that have been applied to whooping cough? Or you're not sure?
I'm trying to remember. I thought whooping cough was viral.
I could be wrong totally. Moving on. Sorry, I'm just trying to get some clarity.
Nope. You ask a good question that I can't answer.
It could be because I know it's used to treat like airway infections like bronchitis and pneumonia. So maybe if you had a related condition, that could be it. I'm no expert either. Just giving my 2 cents here.
Pertussis is a bacteria, so yes, amoxicillin is probably what you're thinking of. Okay. Now, back to the slideshow. Unfortunately, all the words erase when I change screens. So I was listing herd immunity levels, and we're talking about smallpox. Smallpox herd immunity needs to be between 80 and 85% of the population. So the more contagious something is, the easier it spreads from person to person, the higher the percentage of the population needs to be immune to protect those who are susceptible. And now I want to talk about inoculation and variolation. This woman, she was a British woman, Lady Mary Wortley Montagu. Obviously, very well-to-do, high society kind of person. And her husband had business in the Ottoman Empire. Specifically in what is now Turkey. So the Ottoman Empire was bigger than just Turkey at various times in its history, but generally speaking, it's kind of the Turkey area. And the Turks, the West Africans, and Asian and Indian people that she interacted with used something called variolation to protect themselves and their children against smallpox. And this is something we've talked about previously, deliberately exposing people to a milder form of smallpox to try and protect them from a more severe case. And so the way they would do this was they would find someone who had a mild case, and they would collect the scabs. And then they would scratch the skin of a healthy person and insert powdered scabs into the wound. And it usually resulted in a milder case of smallpox. The mortality rate of variolation was between 1 to 2%. So higher than we would accept in modern times with, I spelled words, with our modern medical care, but it was much, much better than smallpox. Nate, go ahead.
So I know it's like theoretically it's, you know, a different concept than vaccination, but would you say that this was like the great grandfather or like prototype of modern vaccines?
You are right on the ball, Nate. This is exactly where we're going with this conversation. This is kind of the precursor of modern vaccinations.
The predecessor.
The
I guess.
predecessor.
Yeah.
Remember, smallpox is a respiratory disease, and it can be transmitted by, you know, respiratory pathways, breathing in the virus particles. Putting the smallpox into the skin instead of into the lungs, that in itself produces a milder disease because it's not impacting the tissues where it can reproduce at the highest rate and where it causes the most damage. And the people who were variolated still had lifelong immunity. So it was very, very effective. Lady Montagu was a smart woman, and she recognized what was going on. And so she said, we're going to do this to my kids. And she had her children variolated. Then when she and her husband went back to Europe, she started talking about this amazing thing that she had found in the Ottoman Empire, this amazing treatment. Now, being a very rich white woman, she was able to get experiments done. And the experiments were done on, of course, orphans and prisoners, our favorite volunteer groups. We're going to see this again. Her social standing helped convince other wealthy and royal families to variolate their children. And once royalty got on board, then it became popular and widespread throughout Europe. There was a risk that people who were variolated could spread the disease to susceptible people. So a lot of communities would have people stay at home or in a hospital until they were recovered from the mild disease from variolation to try and prevent a major outbreak. And if you've heard about the fact that George Washington vaccinated the troops, it wasn't really a vaccine, it was variolation, and it was for smallpox. And this was really important during the American Revolution because the European troops were likely to be immune. They either survived it or they'd been variolated. And if the American army had not variolated their troops, they would have lost a lot of troops to smallpox. And a lot of people like to speculate that the US would have lost the War of Independence because there wouldn't have been enough troops. Okay, screenshot time. I do want to point out again, this technique of variolation, we don't know where and when it began, but we know that it was widespread in Asia, India, the Middle East, and West Africa before the Europeans discovered it. So while I'm talking about the European discovery of variolation, again, it's because that's where the Western world has the most written documentation of this type of history. Okay, so over here on the right, this is a variolation tool. This is the tool. It looks kind of like a needle, except it's open at the end. And this is what they use to scrape the skin. Going from variolation to vaccination. Dr. Edward Jenner. Made the observation that milkmaids did not get smallpox. And when he started looking into this, he was a country doctor. And so he saw a lot of people who interacted with cows, and he realized that they would catch cowpox. Now, cowpox is a mild disease in people, but it gives you lasting immunity against smallpox. And he figured this out. He made that deductive leap that deliberately giving people cowpox might protect them from smallpox. So I got to clear this and go on to the next slide. Nate, go ahead.
Sorry, I have a lot of questions. So I guess that's due to the viruses having relative genetic similarities. But I don't want to say that, or I guess this is me making a deduction. That's not always the case, right?
Right.
Like if you had MERS, you'd be immune to SARS, or if you like something like that. So it's not always like set in stone like that, I guess.
It varies between different diseases, absolutely. And cross immunity generally occurs between closely related viruses, but not always, because what our immune system responds to are proteins on the surface, and those are the ones that are most likely to change through time. So the longer two viruses have been separated, evolutionarily speaking, the less likely there is to get cross immunity.
That makes sense. Thanks.
Yeah, we can see this with the flu, and we are going to talk about the 1918 flu pandemic and flu in particular. Every year we get new flu shots because the flu virus changes and evolves. And if you got the flu last year, you might not be immune to it this year because it changed surface proteins.
Could the same be said with COVID-19 and why there might be a need for yearly COVID shots?
One of the big problems with COVID-19 is that immunity seems to wane pretty quickly. So even people who've been infected do not stay immune long term. People who've been vaccinated do not stay immune long term. And the immunity from one strain, so like when we went from, Alpha and the vaccine version and Delta to Omicron, the immunity to Omicron was not as good. So we had a lot more breakthrough infections. And people who got the Omicron strain appear to have very poor immunity against Delta and Alpha. So, even within one disease, we can have this kind of problem. It's still kind of early. It's still early in the pandemic, and there's still a lot we don't know about COVID. Julia, go ahead.
You probably confirmed this already. I just want to make sure. So there are different variants of the coronavirus. Does that mean like the Delta strain, like that it's a mutated version of it?
Yes. The strains are constantly mutating, developing new strains. With a disease that is as widespread as COVID is, there is a lot more opportunity for the evolution of new strains.
Yeah, I was just wondering too, didn't the Delta variant show up in South Africa, or is that the Omicron one?
Omicron showed up in South Africa.
Yeah, so I was just wondering, maybe is it the environment in South Africa that caused the mutation, or I don't why is it in Delta? Didn't that pop up in the UK or something?
I don't remember where Delta popped up. The environment has nothing to do with it, with COVID. It's just chance. So when you are infected with a virus, your cells will produce millions or billions of new virus particles every single day. So if you've got that many being produced, the virus can get genetic mutations, and it's not a big deal for the virus. Because if you have a billion offspring, who cares if 1 million of them have genetic mutations that are lethal?
Yeah.
If you've got 100 that have a genetic mutation that allows them to evade the immune system or spread easier, then those 100 mutants can get out and spread to other people. The more people who are infected, the more likely it is that somebody's going to have those kinds of mutations happen.
Okay. Thank you.
You're welcome. Okay, so in 1796, Jenner decided to test his hypothesis that cowpox provided protection from smallpox. And I see Nate looked up Delta originated in India. Okay, thanks, Nate. And he inoculated a child named James Phipps, an 8-year-old farmhand. 8-year-olds were working back then. And he got the cowpox from a cow named Blossom. So variolation is scratching the skin and putting the disease on the skin. Inoculation is injecting the disease. So variolation, scratch the skin. Inoculation, inject. All right, now, times were different. Ethics were not so good. Jenner deliberately exposed Phipps to smallpox. He did not get sick. Grew up, had a normal life. So that was the first person who got what eventually became known as the smallpox vaccine. And we came up with the term vaccination because vacca is Latin for cow. So that's where the term vaccination came from. This is a painting of Blossom, and this is her hide. So this is the cow that started vaccinations. Jenner was a very forward-thinking guy, and he declared his discovery had the potential to rid the human race of this most dreadful scourge of a disease. He wasn't very modest, but he was actually correct. Vaccination with cowpox had very, very little risk to the individual and no risk of causing an outbreak of smallpox. Jerry, yes.
So what did he inject James with though? Blood? Like I'm confused. They didn't have the research facilities your mom and you worked at then, so.
Us from the scabs on Blossom.
Okay. Imagine being that kid's parent, like, all right, yeah, that makes sense. Let's try this thing no one ever did. And what is it? Pus, the smelly, gooey stuff? All right, put it in them.
Jerry, I don't know that his parents were told about it. And to be fair, Jenner did then vaccinate his children too. So, okay.
One more thing, sorry. So was there a medical journal? There's no internet. So how was he able to get this information out to people 226 years ago?
There were medical journals back then.
It took a long time to get them around though. They was on horseback, weren't they?
Yep.
Okay.
But the great thinkers were all going to be in London.
Oh,
so the
true.
Politicians and the medical schools would have early access to this and be able to disseminate the information that way.
Okay, cool.
Yeah. So vaccination with cowpox, low risk, no risk of smallpox outbreak. Okay, screenshot. Now, unfortunately, at this same time that Jenner came up with the first vaccine, there was the earliest anti-vax movement. So this is a cartoon that was published by the Anti-Vax Society. And these people are vaccinated from a pox from a cow, and they break out in cows all over their bodies. So we had libertarian types back then, and they didn't like government powers being used to force people to be vaccinated. Does this sound familiar? Same shit still going on today. Religious extremists thought it was an unnatural violation of God's order. God wants us to die of smallpox. Others suspected that inserting something from a cow would make humans part cow, which is what this cartoon is showing. Still others claimed that Jenner was trying to overthrow his own government using vaccination. Do these arguments sound familiar? Yeah, it's the same things that people are saying today. So over 200 years ago, people were making these claims and none of them came true, right? We didn't turn into part cows. Jenner did not overthrow the government. Yeah, crazy talk. All right. I just wanted you to know, I just wanted to talk about that because, you know, things don't change. So there were some problems with the vaccine. Cowpox did not survive. It was not viable for long outside of a cow. Viable means capable of being contagious when we're talking about viruses. If we're talking about something that we consider living, we say viable is capable of living. So if an area, if a community wanted to vaccinate their society, they needed a fresh source of cowpox. Generally, this was done by infecting a calf. Calves were more vulnerable to infection, just like children are more vulnerable to infection. Once a cow gets cowpox, it's not getting cowpox again. So once it's healed from cowpox, you can't infect it. So they would infect a new calf and walk it to towns and get the material off of the calf. It's a way of transporting the vaccine. Not only were calves used because they were, more vulnerable, but also because it was a hell of a lot easier to walk a calf from town to town than a full-grown cow. Full-grown cows are big. People could also be used to transfer cowpox. So when somebody was infected and had cowpox sores, doctors would open the sores, soak a thread in the pus, let the thread dry, and carry it to the next town. Now, this was not as effective as going straight from the cow. And certainly you could also go straight to the next person. So you could, get pus off of this person and then go and vaccinate, everybody in the community. Okay, screenshot time. Now that worked great in England, right? You got your England here. It's a little small country. You can walk it around. You can even walk a cow around France and Spain and Europe. But what about the rest of the world? How do you get cowpox to the Americas? The thread method would not work. The thread did not keep the vaccine viable that long. And transporting cows, well, the amount of time it took to get across the Atlantic, the cow would have recovered. So in 1803, the Spanish government used 24 orphan boys to transport cowpox across the Atlantic to the Spanish colony.
Okay to anyone. I just don't understand how the human mind could think that this is a good idea.
Right there with you.
I say this though, those kids were fed at least. You have to understand back then they were really on the street, not like the people in California where it's warm and whoopty. They're really on the street starving, like no shoes. It was crazy. So those kids possibly were fed and warm.
Yes. Jerry does have a very good point there. Orphans during this time period, it's not like there was a foster care system or orphanages. Well, orphanages were basically work camps. These kids were likely to starve to death on the streets or turn to prostitution. So this is a great ethical conundrum, though. This story about using these Spanish boys, these Spanish orphans. So Dr. Francisco Javier de Balmas and Isabel Zindel Gomez collected these boys and led a team to transport these boys and to spread the cowpox vaccine through the New World. So right before they left Spain, they infected 2 boys, 2 of the orphans. Then 9 to 10 days later, the ship's doctor would transfer the infection to 2 new boys. And they did this all the way across the Atlantic Ocean. Because after 2 weeks, you're cured of smallpox, of cowpox. So you can't be used to transfer it. When the ship got to the coast of Venezuela, the last 2 boys were the ones infected. So they barely made it in time. So they get to Venezuela down here, and then they can infect new people with cowpox to protect them against smallpox. Again, they used boys to transport this. Children. Now, the boys that traveled across the Atlantic were told they would be well fed and would get an education in the Americas. Plus, they would have a chance of being adopted. I don't know what happened to the boys when they got to America. I don't know. I couldn't find anybody, I couldn't find any source that talked about what happened to them once they got here. This technique, though, was so successful that Balmas, Gomez, and their teams picked up more boys to carry cowpox around the Spanish colonies. Now, this time, they weren't using orphans. They were using, they were basically paying parents to let them infect the boys and transport them to the next town to carry the cowpox around. And then send the boys back home. It is estimated that they vaccinated hundreds of thousands of people using this technique. And in fact, it was so successful in the Spanish colonies in Mexico, Central America, and South America that when the Balmas hit the Pacific Ocean, he decided, well, let's keep going. Got some more children, went across the Pacific Ocean to China and vaccinated throughout Asia. Probably this technique and this particular guy, this doctor, using this technique saved millions of lives. And they did it without modern transportation methods or refrigeration. Today, cowpox is rarely found in cows. So it's not very common. And people almost never get it. And nowadays, when they get it from cats. Because it turns out voles are the reservoir species of cowpox. Cows would catch it from voles.
What are voles?
They're small rodents.
Yeah. Okay. Thank you.
So nowadays, when people get cowpox, it's usually from cats that went outside, caught a vole, caught the cowpox from the vole, and transmitted it to people. All right, so that is the early vaccination history against smallpox. Questions or comments? Anybody want to talk about the ethics a little bit? Nope.
If those kids were treated well and fed, I don't know, man. The bar is lower than, you know.
Yeah. It's a tricky question. If the kids were treated well, they saved millions of lives, and they got vaccinated against a deadly disease. But we didn't have ethics review boards, and we didn't have informed consent. And I don't know what happened to the kids. So it is an interesting conundrum there.
And say in India, they worship the cow. I wonder how that went over with them using cows in that manner.
Ooh. That's a very interesting question, and one that I don't know anything about. No. Okay. Now, eradicating smallpox. Smallpox today exists in a few places. In freezers, in laboratories, in Russia and the US. There may be some specimens in freezers somewhere else that we don't know about. Only the US and Russia admits to having smallpox. And there is the possibility that some bodies buried up in Siberia, northern Alaska, Canada, might still have virus in them. And one of the concerns is, if these bodies thaw, could the smallpox come back? It is something that we're not sure about. But that's it. It doesn't occur in the wild. It doesn't occur in people since the late 70s. So the eradication campaign started in the 1950s. A group called the Pan American Health Organization decided to eliminate or attempt to eliminate smallpox from the Americas, Central, North, and South America. They reduced it significantly. They didn't completely eradicate it right off the bat like they were hoping. You can see here, Brazil still had cases into the 1970s, but in the US, it had already been cleared by the 40s. In the 50s, a lot of Central America, some parts of South America, and then into the 60s for most of South America. So it was working. It wasn't perfect. In 1959, the World Health Organization, WHO, developed a plan for global eradication. In 1959, there were 2 million deaths a year. The US and the Soviet Union donated vaccines. This was a competition between the US and the Soviet Union, or Russia. Was it Soviet Union? Hang on. Yes, there was the Soviet Union at that point. The US and Russia / the Soviet Union have long been opposing powers around the world. So we can see Brazil here, it was a hard job to eradicate it in Brazil. There were a lot of what are called uncontacted tribes. Tribes of people who did not have interaction with the more developed parts of Brazil, the more developed cities and communities. A lot of cases were not reported in Brazil. And the vaccination teams were getting rewarded for how many vaccines they gave out. So they started falsifying the reports. In addition to that, the vaccine quality that was being used in Brazil, it wasn't very good. If it's not refrigerated properly, it would go bad and wouldn't be producing an immune response anymore. So there were a lot of problems with that. So they used a process called surveillance containment. As smallpox was declining across Brazil and in other places as well, there were rewards given to if you notified the health department of cases. So now we're paying people to confirm smallpox cases. When a smallpox case was found, everybody who interacted with the patient would be vaccinated. So you kind of create a ring of protected people. Anybody who interacts with somebody exposed or who has smallpox gets vaccinated. Now, in many places, resources were limited. And so these might be the only people you could vaccinate, the people who potentially could have gotten exposed and spread it. But it works. And UNICEF was one of the major organizations that provided free vaccines, especially to the more impoverished communities. South America was the first continent certified free from smallpox, and it was certified free of smallpox in 1973. So if you look at that, the Pan American Health Organization started this campaign in 1950. 23 years later, South America is free of smallpox. Now, if we look at this map, we can see that North America was free of smallpox before that point, but South America was the first one who got certified. All right, so that is Brazil. Take a screenshot because we're going to talk about a couple of other places where there were problems. And the next place, Zaire. So this is in Africa. And in this country, the problem was corruption. You could buy certificates of vaccination. And in fact, they required everyone to have a certificate of vaccination, which cost money, time, and slowed the progression. It slowed how many people could be vaccinated because you have all this paperwork to fill out. Instead of just going, pop, there you go, you're done. You have to stop and do paperwork. And the government would not release money for smallpox eradication until the local community or organization doing vaccination completely ran out of money. So they wouldn't keep passing on the money. They were holding on to it as long as possible. So you end up with this start-stop process, and people would, you know, the hospital would run out of money, or the organization would run out of money. People would quit their jobs or get, you know, not get paid. So they would leave their jobs, and then you have to hire new people. And that really slowed things down. And then there was South Sudan. Now, Sudan is, I think we're talking about right here. It's right in this area, at least. At the time, it was a war zone. And the rebel forces, the Anyanya, oh, I don't know that I have any idea how to pronounce that, resistance movement, they wanted to vaccinate. They wanted to vaccinate their communities and they wanted to vaccinate their forces, but the government said, no, you're the bad guys. You're the rebels. We are not going to give you vaccines. Not going to happen. This isn't a bad news story because this resistance movement would walk on foot to Uganda. And at the time, this was 7 to 10 days through wilderness. Get supplies and walk back. Now, the World Health Organization could only legally provide vaccines to government-run programs. So the rebels, the World Health Organization would not officially give them the vaccines. But the staff in Uganda got around this. They illegally supplied the rebels with vaccines and listed them as lost or degraded. So they were not officially providing the vaccines. So good on them. That's a good time to break the law. The last naturally occurring case. Oops, I'm going to go on to the next screen. So screenshot. The last naturally occurring case was in 1977 in Somalia. The World Health Organization rushed in, vaccinated everyone in contact with the child, and stopped that potential outbreak. Now, we mentioned the smallpox vaccine provides a scar. The scar is on the back of people's arms. We don't vaccinate against smallpox except military because we've eradicated it. Does that mean that we're all safe? We don't have to worry about it anymore? Well, we know there's some in freezers. So there's always a concern there. Because what happens if smallpox comes out and we have a virgin population where only people over 50 have a vaccine, have been vaccinated? It would be really nasty. And it's one of the big fears of people who study bioterrorism is that smallpox could be used.
Why is there a scar on their arm? It's from the shot. I'm confused.
Yeah, the spot where they inject the smallpox vaccine, you get a localized set of pox similar to cowpox
okay.
or smallpox,
Okay.
and it leaves a scar.
Okay.
Yeah. All right. Now, notice that I said 77 was the last naturally occurring case. This is Janet Parker. Janet Parker was the last person to die of smallpox. In 1978, she was a photographer at Birmingham Medical School in England. She contracted smallpox. Her mother also contracted it. Her mother recovered. She died. This was probably due to poor ventilation and poor lab safety practices, because there was a researcher by the name of Harry Bedson who was working on smallpox. Now, he wasn't following all the legal requirements for working with smallpox. He wasn't following the regulations to keep it safe. And so she wasn't in his lab. So we think what happened was some smallpox got aerosolized, it got released into the air, went through the ventilation system, and went to where she was working. Bedson later committed suicide while he was quarantined at home.
Why? So she couldn't get the vaccine?
With smallpox, the vaccine does not work if you've already gotten the disease.
What? Oh, wow.
It only works as a preventative.
So there's nothing that can save you if you have smallpox. I didn't know that. That's it. Wow.
No, that's if smallpox erupted today, half the people on the planet would get it, and a third of those would die.
Wow. And how long do you takes for you to die from when you first get it? A few weeks?
It's a couple of weeks, yeah.
Oh, so hence you're saying that they have that. It could be for biological warfare. Wow. That's
Yep.
the scariest thing you ever told me in class so far.
It's probably the scariest thing I will tell you in class. I can't find it in my notes right now.
Look it up, but wow.
Yeah. All right, so she was the last person to die of smallpox. You could argue that Bedson was the last victim of smallpox because he did commit suicide. You can't blame him. I mean, there was the chance that he had released it back into the world, which would have been horrible.
So she died of smallpox, and then Henry Bedson committed suicide because he had it, right?
No, he didn't have smallpox. He committed suicide because his poor lab safety practices caused her to be infected.
Oh.
And there was a chance that it would get out.
Okay, thank you.
Remember last week we were talking about the different tiers of safety that labs have? So what tier of safety should that lab have? I remember you was talking about negative air pressure. You know, the air doesn't leave the room. It shoots out through a chimney or something and gets purified on the way out to the rest of the world.
Yep.
So what tier should that have been?
Nowadays, well, nobody works on smallpox these days, but it would be considered a BSL-4.
Whoa, a 4?
Which is, yes, because it's highly contagious, very deadly, and spread by respiration.
Scariest thing ever. Okay.
Yep.
Cool.
All right. So the world is now free of smallpox. Aren't we happy about that? All right, I'm going to go on to the next screen. And I wanted to mention the only other disease we have ever eradicated completely from the planet. There's a disease called rinderpest. It is a disease of animals in the group called the even-toed hoof stock. So cows, goats, wildebeest, giraffe, those sorts of animals. And in some cases, the strain would kill 90 to 100% of the exposed animals, even deadlier than smallpox. Generally speaking, if somebody in Europe, if their herd had showed up with rinderpest, they would kill the whole herd. In the 1970s, I'm sorry, the 1700s, it killed 200 million cattle in Europe. In the 1800s, it was carried to Africa, where it nearly wiped out all of the cattle, but it also affected wildlife. Things like Cape buffalo, wildebeest, a lot of the small antelopes. And in fact, in some areas, the populations never fully recovered of these wild species. But rinderpest was eradicated in 2001. So you don't have to worry about this one. And there are two diseases we are extremely close to eradicating. Polio. Polio is only found, well, as of last week, in 3 countries in the world: Pakistan, Afghanistan, and last week, one person was diagnosed with polio in Malawi, which is a country in Africa along the Rift Valley. In 2019, there were 176 cases worldwide. So this went from a disease that when my mom was a child, everybody was terrified of, to a disease that only occurs in a couple of places. And Pakistan and Afghanistan are very hard countries to do health outreach in, for lots of social reasons, for warfare reasons, and just because the terrain is incredibly difficult. There are lots of communities that are very, very hard to get to. The other thing that is almost eradicated is a parasite called guinea worm. In 1986, there were 3.5 million people infected. In 86, it occurred across Africa and Asia. Our former president, Jimmy Carter, and his Carter Center set out to eradicate it. Last year, there were 14 cases. It's listed as occurring in 5 countries in Africa, but we're incredibly close to completely eliminating this one. Fingers crossed we can actually do that. All right, but cowpox, our first vaccine ever. And we did not have an understanding of germ theory at that time. Even after we developed the vaccine, it would take about 100 years to understand how vaccines work. So we're down to the last few minutes. I don't want to start on talking about how we really started understanding vaccines and understanding germ theory. So we're going to talk about that next time we meet. Any thoughts or questions? Nate, nothing come to mind? All right, in that case, we will end it here and I will see you guys next time.
Thanks, Professor.
Bye.
Thank you.